This is question number 17 from chapter 7. It reads, a tennis ball of mass 0.06 kilograms and speed 25 meters per second strikes a wall at 45 degrees and rebounds with the same angle. What is the impulse, both magnitude and direction, given to the ball? I've made a sketch that represents what's going on in the sketch in the textbook. And I think it's important to kind of visualize this by drawing a little coordinate axis here, which I've done. I've drawn an XY axis. If I were to make just kind of a quick sketch of the vector direction of its motion, so I'm going to draw this up and to the right. That's the actual speed, or in this case, velocity vector. That could be resolved into an x component, which is going to be to the right, rightward, and a y component, which would only be upward here, v sub y. If I were to do the same thing on the rebounded ball, well, by the way, let's go ahead and acknowledge that this angle right here is equal to the reflected angle. In optics, that would be the law of reflection, where the incident angle is equal to the reflected one. But anyway, let's go ahead and take now a look at that velocity vector after the collision with the wall. We can say that it's up and to the left, so therefore the y component, v sub y, would be going up, and the x component, v sub x, would be going to the left. If you pay attention to the y components, you'll see that they're not changed. So I've got a y component that's going up here and a y component that's going up here. And so the momentum then, of course, mass times velocity of that ball after impacting with the wall is not going to be changed in the y direction. Only the x piece actually changes. So it's initially the x piece is going to the right, and then after the collision with the wall, the x piece is going to the left. So that should be really part of your problem solving. And so in this question, we can say that the impulse is going to be equal to the change in momentum. I've kind of written it in short form here. Impulse is equal to the mass times the change in velocity, which is another way of describing a change in momentum. And so I can then say that the impulse in this case is the mass times v final minus v initial. And only the x components are really changing, so I could apply these subscripts x here if I wanted to. It's really not required, but you could certainly do that. So let's go ahead and do this. The impulse in the x direction is the mass. Now I'm going to resolve this velocity vector into its x component. So the final x velocity is going to be to the left, so it's going to be negative, and it's going to be v times the cosine of the angle 45. V cosine 45. So there's the x component final, and I need to subtract that. Let me go ahead and put this in another set of brackets. I need to subtract that from the initial velocity, which is going to be to the right and positive, which is going to be v times the cosine of 45. Again, close brackets. All right, if you look carefully here, I've got negative v minus another v. That's going to give me negative. So let me carry the mass down. It's going to give me negative 2v cosine 45. If you want to, you could have plugged numbers in earlier and you would have just eventually got there. And so now I'll see that the impulse is given to me by multiplying the mass, which is 0.06 kilograms. And I'm going to multiply it by negative 2 times the velocity, the speed in this case, which is going to be 25 meters per second, times the cosine of the angle 45 degrees. When I run that through my calculator, I'm going to get something that's negative. Of course, that negative sign here is going to carry forward into my answer. I get negative 2.1. And you can use a variety of units here. We can use Newton seconds to describe an impulse, which would be sufficient for my answer. But you could also use other things as well. I'm going to use this one here. Kilogram meters per second is also an appropriate unit. Of course, a Newton is a kilogram meter per second squared, so when you multiply a Newton times a second, you get a kilogram meter per second.